Yesterday we made our code more intelligent by adding a match case block. So this is what our code does currently. We declare an empty list just here, and then we run a loop over and over again. So all these lines will be executed over and over again. So we get some input from the user, we get add, show or exit, and then we strip that out from white space, and then we remove the white space from the user input, and then the program tries to guess the user input. So tries to guess if it's add, then it gets the to-do from the user. Again, it asks the user for input, and it appends that to-do in a to-dos list, which is declared in here. So those lines are executed if the user entered add here. If the user entered show, then we iterate over the existing to-dos lists, so that list. So if there are items there, those items will be printed out in the command line. And if the user entered exit in here, then this break statement is executed and the while loop terminates. So what we get is we get this line executed because there will be no more iterations anymore in the while loop. The break statement breaks the cycle. And that's what we did yesterday. Let's write some more intelligent code today. See you in the next video. At this point of the program development, we allow the user to add and show to-do items. The user can also exit the program. But in this video, we want to add a new feature, a new edit feature, which allows the user to edit existing to-do items. So how do we go about adding a new feature? Well, to be able to add a new feature, you should think from the user's perspective. So try to be in the user's shoes. So let's run the program as it is now. And let's think as the user. So this says type add, show or exit. So the first thing we want to do is we want to add here an option, edit. So type add, show, edit or exit. So if we run this now, we're going to get the correct prompt. Then the user might want to press edit here. We want to add a new case to count for that scenario. So case edit, a colon, press enter, PyCharm indents automatically the next line. And here, what can we write? Well, for now, let's just say print got it, just something dummy, and rerun the program and try again to think as the user. So the user wants to press edit, but first they want to add something like add a new to-do clean, add throw, add prepare. And then they want to press edit. So we pressed edit, got it, was printed out, so that case statement is working fine. But let's think of how do we want to tell the program which of these items we want to edit. So in this command line interface, we have basically two options. So either we should say that we want to edit clean and we explicitly type down the exact to-do item there, and then the program asks us a second question such as what do you want the new to-do to be, and you write the new to-do which will override the existing to-do, or you just say the number. For example, you want number 2, so you want to edit number 2. I think the second scenario where you just tell the number of the to-do is more meaningful. So the user first says show, it knows the order of these, and then it says number 2, edit. And then the program asks again the user to enter the new to-do for that to override that to do, and so on. So let's close this and go to the program. So if the user enters edit, we want to ask the user a new question. Let's say number is equal to input number of the to do to edit. So we ask the user to enter the number of the to-do item. So if the user enters 2, for example, 2 will be stored in the number variable. Let's see if we successfully get that. So print number, run again. So let's say edit 2, and we get out 2. So what can we do now with this 2? Well, we will use list indexing system to be able to extract that item of the list which has an index of 2. So let me give you an introduction to this list indexing system. Let's say we have the list to-dos is equal to clean, throw, and prepare. So that's the list. So if you want to extract that item from the list, you do to-dos square brackets 1, and that will give you throw, which of course you can also store that in a variable. To-do is equal to that, to-do is equal to throw, and that's the list again. Sorry, to-dos is the list, and to-dos 1 gives you throw. Why? Because this first item has an index of 0, this second item has an index of 1, and the next item has an index of 2, and so on. So what we're doing here is we are accessing the item with index 1, which is the item throw. So that means if you press 0 here, you get clean. If you do 2, you get prepare. If you write 3, you'll get an error because it says list index is out of range. So there are no items with index 3. So back to our program. We get the number, so the index, and we use that index to access the to-dos list. So number here. And that will give us the to-do item which the user wants to edit. And what do we do with this now? Before we answer that question, let's make sure we got this correctly. So let's call this existing to-do is equal to that, and print existing to-do. Let's see what this is going to give us. So I'll run this. Let's add a new to-do, clean, add a new one, prepare, show the to-do list, clean, prepare, then press edit to edit a new one, number of the to-do to edit. So that is 0, that is 1, but the user doesn't know this. So the user maybe will write down 1 to mean that. So we need to adjust for that in the script. We'll do that also. So let's try to enter 1. And we get an error. The error is in line 16. So it's here. It says that type error, list indices must be integers or slices, not str. So it seems that the index is a string. What is the index? The index is this part here, this number that we give in here. But the interpreter is saying this is string, and this is true because the input function always produces a string type. So even if the user enters a number, that number is actually a string. It is just text. It is not recognized by Python as a number. So let me show you what I mean by that. Let's say you want to store in variable a, you want to store the input. Enter a number. So you enter a number, let's say 10, right? And you might think that a now is a number, right? So if you do a plus 2, you will get an error because you are trying to concatenate a string. So 10 is a string, you can also see the quotes here, with a number. And that doesn't make sense for Python. The interpreter is confused, doesn't know what to do, so you get an error. The solution here is to use a function which converts a string to a number. So that function is int. If you write 10 here, it will give you a number. So let's say b again is int 10, type b is int. So integer is a whole number in Python. You can also use float. Let's say we have this string. You press enter and b now is a float, so it's a decimal number. So float converts strings to decimal numbers and int converts strings to whole numbers. So type b is a float. Right, so we use that to convert this into int. So if you say int here and you wrap that inside int, so the output of the input function will be the input of the int function. In other words, the output of the input function is 1, so 1 will be the input of the int function, and we get 1 as an integer, a whole number. So we need to work with whole numbers here, because indices are whole numbers. So we had the to-dos list, to-dos, you cannot say 1.3, you'll get an error. You can only say 1 or 2 or and so on. Right, now number is an int, so now we shouldn't get an error anymore. So let's run this. Add clean, add throw, show, edit. I'll edit number 1, press enter, and we get extracted the throw item from that list. So number 1 extracted throw. But as a user, I don't know about the indexing system of Python. I don't know that Python starts the indexing from 0. So we, us as a programmer, we need to adjust for that lack of knowledge from the user's part about the system that Python is based on. There's an easy solution for that. We just go to our script. So we grab the number. Let's say the user entered 1, but they meant 0, right? The first item, but the item has an index of 0. So we say number is equal to number, so 1 minus 1. So we get 0. If the user enters 1, 1 minus 1, we get 0. If the user enters 2, 2 minus 1, we get 1, and so on. Right, so that should give us the actual to-do that the user wants to edit. But then how do we go about replacing that to-do? So we have the list to-dos. Now with to-dos and 1 we got the item. But if you want to replace that item, we say to-dos 1 is equal to new item. Whatever the user enters here. Press enter, and now if you check to-dos, you see that throw is replaced with that new item. Therefore, we go in here, and instead of doing that, we say to-dos number, so throw is equal to new to-do. What is new to-do? Well, new to-do is something we get from the user using again the input function enter new to do. So I'll run this now and you'll see that this is working well. Add clean, add throw, add prepare, show. So we have 3 items and we want to edit throw. So we count 1, 2, oh, that's number 2. So edit, number of the to do to edit, 2, enter new to do. How about disassemble? Press enter, press show to see the to-dos, and here we have disassemble is the item with number 2. Sorry for the typo, disassemble. Anyway, exit and we exit the program. So that's the final version of the edit feature. Let me delete this break line. So what you learned in this video was how to convert from a string to a number using that int function. You also learned how to access items from a list using that syntax, and you also learned how to replace an item using that syntax. This was quite a long video, but these features are very crucial for you. You're going to use them in every application that you'll build with Python, no matter if it's web development, data science, or other fields of Python. So thank you for following, and I'll talk to you later. Hey, welcome to today's code experiment. Today I'll run a few code experiments so that you better understand list indexing and type conversion. Now the code that I'll be trying out are single lines of code, so for that reason I'll be using the Python console. It's best to use the Python console when you're just executing one-liners. So you saw that if the user entered some input and we store that input in a variable, for example, if the user enters 5 and then you see a now is a string, you see the quotes here, so a plus 10 would not make sense. Therefore, you want to convert a to an integer using the int function, and perhaps store the output in a new variable or maybe in the same variable. It's up to you. I'll store it in a new variable, b. So now b plus 10 makes sense. So b is an integer. You see it's without quotes, and this has quotes around. Now you might ask, why are types important? Why can't we just have 10 and it doesn't matter if it's a string or a number? Why do values have to have a type? Well, I'll answer you that with an example. So again, a is a string, b is a number. Now if you do b times 10, guess what you'll get? Yeah, it's 50. So 5 times 10, you get 50. Now let's try times 10. This is what you get. So in Python it is not possible to add a number to a string, but it is possible to multiply a number with a string. And the output you get is that string multiplied 10 times in this case. So 5, 5, 5, 5, 5, 5, 5 at 10 times, and you get a new string. And of course you can have everything like high times 10, and you get high 10 times. So back to the question we asked, why is it important to have types? Well, the interpreter wants to know the type because it understands better what you intend to do. So if you intend to have that string multiplied 10 times, then you want to have that as a string type. And then the interpreter knows that it is a string type, so I don't have to do a math multiplication. I do a string multiplication if it's a string type. And if you as a programmer mean to do a math operation, then you want to make sure that this value is an integer. So having types for values is important to communicate with the interpreter. So things have to be as explicit as possible. Right, the next experiment. If you do int high, you'll get an error. So that's obvious. You can also use floats. Float high, you will get an error again. So it doesn't make sense to convert that string into an int, and it doesn't make sense to convert that into a float. So floats are decimal point numbers. If you convert string 10 to a float, you'll get 10.0. So that is different from converting string 10 into int. You get 10. So again, we have a different type here. The distinction between floats and integers is not as important as the distinction between strings and integers. But still, you'd want to use floats whenever you are working with continuous data. So if you have a variable which is the temperature, then you want to work with a float. If you are working with whole numbers, such as the number of persons in a company, you want to work with integers. Now, Python has this implicit declaration of types, so you don't have to use the float class when you create a variable. So if you just say x is equal to 10.1 and you check the type of x, you'll see that x is a float. But if you do y is equal to 10, you'll see that y is an integer. So if it doesn't have that dot, it's an integer. If it does have that, it's a float. And of course, if you use quotes around it, it doesn't matter if it does have the dot or not, type of z is gonna be a string. If for some reason you want to convert a number into a string, you can use ASTR. You not only convert integers to strings, but also floats to strings. You could ask, when would you need to convert a number into a string? Well, you'll see that when we create apps, then this str function can sometimes become useful. For example, if you want to write some text in a text file via Python, there is a method for that, which you'll learn later on in a few days from now. And in that case, you cannot write number data types to a text file. So if you have a number, you'll have to convert it to a string and then write the output in that text file. And then the number would show in that .txt text file or other file formats that Python is able to create. Let's run a few experiments on list indexing now. So let's create a list. My list is equal to A, B, and C. The first thing I want to make sure you understand well is that each of these items is treated as an object. So you can extract the object, you can store it in a variable, for example, as z is equal to my list 1, and z will be string b. So the type of z is b. Sorry, the type of z is a string. That b was another variable which we declared somewhere in here. So z is a string. And with that we extracted the item with index 1. So a has an index of 0, b has an index of 1. That's why we get the string b. And of course you can do other operations. You can say z is equal to b, you get true. Similarly, you can say my list 1 is equal to b, you get true. So my list 1 and z is the same value. So both these point to the same value. Now, how do we get the index of one object? Let's say we want to know the index of B. To do that, you need to use myList.index, a method, and provide the object you want to know the index of, and you'll get 1. So that is the index of B. So index is listed in the list method. If you scroll here, you'll see index. Now, let's try this method with underscores. So it has double underscores in the beginning, double underscores at the end. All these methods with double underscores are actually used by Python internally. We don't need to use them. But what if we do? So let's try that myList dot underscore underscore set item underscore underscore with 2 parentheses. So this is the same syntax as here. Now this method takes 2 arguments. The first argument is an index. So let's try index 1. Index 1 points to string B. The second argument is the new value you want to set for the item with index 1. So let's say D. You press enter, you check my list, and you'll see that D has replaced B. So that was the previous list, now the list is updated. So that there is the equivalent of saying my list 1 is equal to the new value. So let's try E this time. Now my list will be updated. So now D is gone, E is the new item. So which one should you use? This or that? The short answer is use this. And actually when you use this, on the background, the interpreter actually calls the setItem method. So every changes that are done are being done by methods. But the Python code developers have been nice and they have provided this simpler syntax for very common methods such as setting an item. Similarly, there's also a getItem method. So my list dot get item with double underscores, and let's try 2 this time. I did a typo obviously. So get item with 1t, and we get C. So the item with index 2 is C, and so that is the equivalent of, try to guess it, well, this. So you get C. My list stays the same in this time. So in this case, we're not changing the list. Some methods, such as setItem, change the list, and some other methods simply access some information from the list and they don't change the list itself. So that was a long video on code experiments, but plenty of information. So thanks a lot for following. See you. Hey, welcome to the bonus example of today. In this example, you will learn about mutability, data mutability in Python, which is a concept you need to know. So please don't miss this video. Let's start. I want you to open a Python script and write this line there. So this line is a variable declaration, and that variable is equal to a list. The list itself has 3 strings, 1 here, 2 and 3. So let's suppose that we had a folder here and that folder has 3 text files with these names. And we want to change the dot of each file name to a dash. So we're talking about doing something to each of them repeatedly. In that case, we're thinking about a for loop. So for file name in file names. Press enter, and so in the first iteration, file name would be equal to that string. So how do we replace the dot with a dash? Let's open the Python console to try things out here first. So file name in the first iteration is equal to that string, right? Now file name square brackets 1 gives us access to the dot. So we access the dot character. Now in the code that we wrote today in our app, you saw that we had this syntax. To-dos was a list and number was an index, just like this index here. And new to-do was the new item that replaced that existing item. So can we use the same syntax here and say file name 1 is equal to a dash and expect that the dash will replace the dot? Let's try this. It doesn't work. We get a type error, and the type error says str does not support item assignment. So that syntax there and that syntax here is the same. We are assigning an item, a new item, to the list in this case and to the string in this case. But it seems like strings don't support item assignment, and that is because strings are immutable. They cannot be changed, and lists are mutable. You can change a list. So we had the to-dos list, clean it, throw it, and so on. So to-dos 1, get it, and you see that to-dos is changed. So get it is now part of the to-dos list. So now the question is, how do we change something from a string? Is it really impossible because strings are immutable? No, it is not impossible to change it. The workaround is to create a new string. So instead of using file name 1, we use file name.replace, a string method. So file name.replace, and you place as the first argument, you place the character you want to replace and the new character which will replace the old character. So if you press enter, we will get this output. So the character was replaced with a dash. The other dot also was replaced with a dash. That's a problem we will solve in a minute from now, so let's ignore that issue for now. Let's focus on the string mutability. I know you are confused now, because we got the new string here. Yes, but if you check file name, you'll see that it still has the dot. So what's happening here is that replace is a method which returns a new string. You see, it returns the new string. But if you want to keep that string, you want to store it in a variable. So you go here and say file name new is equal to that. Press enter, and now that output will be associated with file name new. So file name new is equal to that new string. But you don't need to use a new variable. You can also say file name is equal to file name.replace, and that variable will be reassigned to the new string. So if you press that, you check file name. Now file name has these dashes instead of dots. So that is how you change a string. It's not exactly changing the string, it's creating a new string and overwriting the variable with a new string. Now how to get rid of that second dash? Well, you'll need to add 1 here, and 1 means only change the first occurrence of the dot. If there are other occurrences in the string, don't change them. So that will fix it, but now file name has the dash already, so that will not do anything. So I'll not execute that, and I'll reassign file name. So I'll get that, copy it, execute it again, and then do that. So that has the dots. Now if I do this and I check file name, I get file name with a dash in front. So let's do the same here for file name. In file names, file name is equal to file name dot replace dot with dash only the first occurrence, and then you can print the file name. So run this, and what we get is the new file names. So we were able to change the first dot of each file name. Now in our example we are simply printing these file names in the command line, but in a real scenario you'd want to use some methods such as file.rename, and you place the new file name there, and each of the files, the actual files on disk, will be renamed using that new file name. But that's something we'll learn later on. So for now, let's simply focus on processing strings. But as you get some clues, you see how strings are useful in real life. So strings can be used to represent file names, and lists can be used to represent a list of file names. So each data type has its own use in real life. You'll see more and more how all the core data types of Python are used in real world applications, which we will build throughout the course. Before I close this video, I want to mention again the aspect of mutability. You could ask the question, why are strings immutable and why are lists mutable? Why did the Python core developers choose to have these two data types that way? And here is the answer. As a programmer, when you write programs, you will run across scenarios where you'll want to be sure that a string in a variable is not changed. There could be different reasons why you might want that, depending on how the different parts of the program are interacting. So you really want that a string is not changed. Now they didn't make strings mutable because if you want to mutate to change a string, you have the workaround that I showed you, that you reassign the output of the method, for example replace, you reassign it with a new variable, and so you have basically a new string which is changed. So you have a workaround to deal with immutable text. But if strings were mutable and you didn't want them to be mutable, then you wouldn't have any solutions. And that brings us to the other question. So why are lists mutable then? Why didn't they make them immutable? Well, it's true, the same problem could exist. When you create a program, perhaps you really want the list not to be changed. But in that case, you shouldn't use a list, you should use a tuple. A tuple is the immutable version of a list, and I'll show you now how a tuple is created in Python. So let me open a Python console. So that is a list with square brackets. If you want to create a tuple instead, what you do is you use round parentheses instead of square brackets. And then the syntax inside is the same as the list. So you can just put all that inside the tuple here. So all the items are divided by commas. You press enter. File names is now a tuple. It has these parentheses. You can check the type as well. Type file names. so it's a tuple. Now it is possible to get the items of the tuple, for example, file name 1, sorry, file names, not file name. File names is the variable holding the tuple, so file names 1, you get reports.txt. Of course, file names is not changed. Even if you use the assignment operator, you say file names 1 is equal to something new, you press enter, and you get the error that tuple does not support item assignment because tuples are immutable. Likewise, the file names tuple doesn't have an append method because append also modifies the list. So it's a method of lists, not a method of tuples. The tuple doesn't even have such a method. So that's the idea. Strings are immutable, and perhaps the Python code developers, maybe they will devise a new type later in the future, which allows us to create mutable strings. But for now, that's what it is. So strings, lists, and tuples. So should you be using tuples or should you be using lists in your everyday programming? The short answer is just use lists because they are more flexible, so they can easily be changed. You don't have to reassign them in a new variable. That's why lists are the most popular when it comes to sequence types that store different objects in them. Tuples are useful in very special cases, and you'll know that when you get more advanced, and you'll see a scenario that, oh, you could say a tuple would be useful in this case. And that's why it's good to be aware that tuples exist. So that was my purpose, showing you mutability and tuples in this video. Thanks a lot for following, and I'll talk to you later. Hey, for today's programming tool, we're gonna talk about IDEs, code editors, and text editors, with a focus on IDEs, and exactly with a focus on the PyCharm IDE. So first of all, I want to explain you the difference between IDEs, code editors, and text editors. What you're looking at is a text editor program. This is Notepad on Windows. The sole purpose of this program is to allow you to view and edit text files. And by text files, we also mean like .py files, because these are also text files, but with a .py extension. So it is possible to program in a text editor. The problem is that you don't have syntax highlighting in a text editor. So as you can see, compared to PyCharm, we don't see different colors for different code elements. So in PyCharm, for example, we have the same color for variables, and then we have another color for functions, and so on. That is not the case when you're using a text editor. So if you want to make your life harder, then feel free to use a text editor. Otherwise, the next in line is code editors. Code editors are things like Visual Studio Code, which I'll demonstrate you here. So this is Visual Studio Code. This is called a code editor. I'll explain you now the difference between a text editor and a code editor, and the difference between a code editor and an IDE. So as you can see, the code is highlighted here. So Visual Studio Code, which is the code editor program here, is able to recognize Python code, and it knows that it needs to use a particular color for functions such as input and print and so on, and another color for variables, so that it makes it visibly easier for the programmer to read the code. Another example of a code editor is Atom. So you don't need to install these programs, I'm just mentioning them here so that you know the difference between these tools and PyCharm. So this is Atom. It's another code editor similar to Visual Studio Code. It also gives you syntax highlighting. And then we have IDEs such as PyCharm. So an IDE has all the features that text editors have and all the features that code editors have, plus they have some tools which makes programming easier. And these tools are particularly used when you get more advanced, a more advanced programmer, and you really have the need to use these tools. For example, PyCharm has a debugger, which we will cover later. You'll know how to use the debugger. It makes it easier to fix bugs, to find and fix bugs in your programs, so to find problems. And you also have code completion in PyCharm. So when you're writing code, for example, PyCharm will suggest you what methods you can use with list. So that is something that text editors don't have. Code editors can also have one or another from these features. So for example, Visual Studio Code also has a debugger. So there isn't really a very defined border between an IDE and a code editor, at least nowadays. So in Visual Studio Code, for example, although it is officially known as a code editor, it does have a lot of features that IDEs have. However, my recommendation is to use PyCharm as the IDE, because unlike the other code editors and IDEs, PyCharm is exclusively built for Python. So basically you can refer to other programs as a Swiss knife, which are built for different languages including Python, and PyCharm is designed for around Python, and it really makes things easier for a programmer. So now I want to focus on explaining you PyCharm. As you can see, PyCharm is constructed of the editor area, which is this area here where we write the code, and then we have the directory tree, which is the place where we see the directories and the files for our project. And then we have the terminal, which can be switched on with this button here, terminal. The terminal can be used to interact with the operating system, so with Windows or Mac, whatever you're using, and you can interact using commands. So you can copy files from one place to another, you can delete files, etc. So that is something we will not cover right now. You rarely need to do those things, but the terminal is just there, an integrated part of the IDE. We also have the Python console in the IDE, which I explained already. So you can use this to interact with Python line by line. And then we have this debugger, which I'll cover later as I explained, and then we have the run button to run the code. So those are the main features of the IDE. To change the settings of your PyCharm, you can go to File and then Settings. On Mac, you can access settings with a shortcut CMD and a comma. On Windows, this is the shortcut. So if you press that, these are all the sections for the settings. So you have settings for the appearance and behavior, key map, editor, etc. Let's look at appearance and behavior, and if you click under appearance, here you can change the font of all the elements but the code itself. So if I change this to, for example, 12, I press enter, and then I press OK here, what we will get is these elements of the program of the IDE will get smaller, but the code stays the same. So if you want to change the font of your code, then you want to go to settings again, and you won't go to appearance, but you want to go to editor. So there you are accessing this editor area here. and you want to go to font, and then here you can change the font of your PyCharm. So if I go to 14 and I press apply, then you'll see that the code here is going to get smaller. So choose whatever you feel comfortable with, but I would suggest not to get lost in a downward spiral with changing settings on your IDE, because I know how it works. You just get distracted and you forget to code. You get distracted with optimizing your IDE. So please try to control that. I'll put this again to 20. And the other thing I want to show you is you can change the theme of your IDE. Under appearance and behavior, appearance and the theme, you have these four to choose from. So if you want a light theme, you can choose that. Dracula is the default theme. One important setting you might want to look at is the project setting. So project, in my case it is Python projects. That's the name of my project, of my directory, Python projects. In your case it could be different. So if you click that, you'll see this Python interpreter and Python structure, or you can expand it and you'll see the same thing here. So Python interpreter, if you go there, and here now this is the Python interpreter that is executing your code. So when you run that triangle button uses the interpreter which is selected in this setting here to run your code. So in my case, this is Python 3.10. This is what I've installed in this machine. So if you have multiple Python installations, you will see multiple interpreters here listed. So you want to select the one that is probably the latest version. To add another interpreter, you can go to this setting gear icon and go to add. And then you want to go to new environment. So you don't have to do this now, I'm just mentioning it. Maybe you need it later. So new environments, and then you select here the base interpreter, which is again the latest version. So that will select a new interpreter. It will not install Python in your machine. You just select that interpreter to be used for PyCharm. So I'm going to press cancel because I have an interpreter now. Now these are packages which we'll cover later, Python packages. So just leave it as it is now. Then we have some advanced settings in here which I'll not cover now. So it's about the debugger, several settings about that. You have languages and frameworks. This is also a bit advanced, you don't need to change this. Under tools, you also have optional things like space, which is a feature of PyCharm. It gives you collaboration solutions, so I'll not cover that either. So the most important settings to be aware of was appearance and behavior, editor, and project here. Under plugins, you have PyCharm plugins which allow you to make PyCharm more advanced, so you can add basically new features to it. For example, one plugin I would like to suggest to use, you can search for Power, and Power Mode 2 is the plugin I want you to consider installing. So if I install this, press accept, and then I press OK. Wait a while. And to be able to activate the plugin, I want to close PyCharm and open it again. And after I have restarted PyCharm, I can code something, and you'll see these sparks So that could make coding more fun, more interactive perhaps. Some people like it, some people hate it. If it didn't activate for you, try Tools and Toggle Power Mode, so try that and try again to code to see those sparks. So again, if you go to File Settings, under Plugins, in Installed now, under Installed, you'll see that this Power Mode 2 is installed as a plugin. To change the settings of Power Modes, you can go to Appearance and Behavior and then click on Power Mode 2, and then you can, for example, you can disable the flames and just have the sparks. Again, I would suggest not to get lost with these optimizations, so just allocate a maximum of 5 minutes changing these settings and then go on and start coding again. So you can press OK to apply those changes. Another cool feature of PyCharm I wanted to show you, which is very handy, is if you have two files, for example, another file, let's say this is main1, and you have main and main1, and if main, for example, is a bit different from main1, so you have coded in different files and you have made some changes, you can compare the two files. You can select both of them with Shift and then right click and go to compare files, which is at the end here. That should show this window view. So here on the left we have main.py, you can see the file name in here, and here on the right we have main1.py. Highlighted in green is the new line that this file has, so you can easily see the differences between the two. You can scroll up and down to see all the differences. In this case we only have this difference. This line is extra here in this main1.py file. You can close that view by pressing that and you go back to main.py. And so that was an introduction on the differences between text editors, code editors and IDEs, and also an introduction to PyCharm. We looked at some settings, so you're now probably more familiar with PyCharm. Thanks a lot for following, and I'll see you later.